Okay, in this lesson we're going to talk about dilations, which are a type of transformation. I've got some practice problems here set up. This one says dilate by c equals 2 around the origin. That just means that the main point is going to be 0, 0. It means things are either going to stretch away from 0, 0 or shrink towards 0, 0. So because c equals 2, that actually means we're going to be enlarging this shape. It's going to be bigger, so it's going to be enlarging away from 0, 0. I like to start by identifying where the points are. So point A is at -1, -2, -3, -4, +1. Point B is at -4, 1, 2, 3. And point C is at -1, +1. Now when we dilate by a scale factor, in this case 2, all we're doing is taking each of these points and multiplying them by 2. So -4 will get multiplied by 2, and +1 will get multiplied by 2. So the new point will be -8, +2, which will be 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, right here. So A prime, the new A, is going to be at -8, +2. The new B, if I multiplied both of these by 2, will be at -8, +6. -8, 1, 2, 3, 4, 5, 6. So B prime is right there. And C prime will be at -2, +2. So -2, +2, right over here. And when I go and connect my dots, I'll be able to see the full triangle. Okay? So this is an example of a shape that got dilated by a number bigger than 1, meaning it was going to enlarge it. We're going to look now at a number that is going to get reduced. This time our scale factor is 2/3. So I have a rectangle here. Let's start again by finding our points. Point A is at 3, 1. Point B is at 3, 1, 2, 3, 4, 5, 6. Point C is at 1, 2, 3, 4, 5, 6, 6. And point D is at 6, 1. Now I need to multiply each of these by 2/3. So if you didn't already know what 2/3 times 3 was, I suggest just finding some scratch paper or some space and multiplying 2/3 times 3, which is really 3/1, which gets you 6 divided by 3, which reduces to 2. So 3 times 2/3 will be 2. 1 times 2/3 will just be 2/3, because anything times 1 is itself. For 3, 6, again, I already know 3 gives me 2. When I take 2/3 times 6, I get 12/3, which reduces to 4. So 6 will turn into 4. Down here I have 6 and 6 again. I already know that's going to be 4 and 4. And I have a 6 again, which is going to leave me with 4, and the 1 will turn into 2/3. So it's a little bit difficult sometimes to graph 2/3, but it's not impossible, so we can do this. So A prime will be at 2 and 2/3, which is going to be just below the 1. So A prime is down right there. B prime is going to be at 2, 4. So 1, 2, 1, 2, 3, 4. There's B prime. C prime is at 4, 4. 1, 2, 3, 4, 1, 2, 3, 4. C prime. And D prime will be at 4 and 2/3. So 1, 2, 3, 4, and then 2/3 is about right here. And I can go ahead and connect the dots as best as I can. And I can see this is how my rectangle looks when I dilate it by 2/3.